Hello everyone, welcome to the system demonstration for the Wikipedia content generation project. So as you can see on the screen, we'll first start with the Tomcat container, just starting it right away because a lot of third-party libraries need to be loaded. So I'll just kick that off and then move on to the explanation of how we get all the files from Wikipedia. So there is this Wikipedia export API which simply asks for the particular category, the articles of which we require for training purposes. So we just put something here. In this case we put diseases and disorders. So once we add it, we can extract all the articles in the form of an XML file. So once we obtain this XML file, we have to process it to get it into a format that is way more readable than its current form. So we use a Python Wiki extractor. It's a simple script that extracts only the content and from that particular XML file, and it excludes all other information such as the revision history and so on. So as you can see, the final file just has a document node with the URL of the current article, the content of that article, and the title of that article. So we also do further processing on this particular file, so the final format, we actually try to get it in a form such that it's way more readable for third-party libraries like Mallet and Weka. So also, as you could see, there were separate sections in each of those Wikipedia articles, but in this case we just concentrate on the top 10 frequent sections. In this case they are causes, classification, diagnosis, and so on. So the final format of the file is basically the section title and the content from those sections, and we extracted around 6,000 articles. So for every particular section title, there will be many such content available from articles within the same category. So once we have this particular file ready, what we do is we train it using a topic model, which is the Latent-Dirichlet allocation model. We run that using 40 topics because that gave us the best results. And then once we have those topic distribution, in this case we actually load it from a model because we already had, we did not want to waste any time running that model in this particular case, but we actually saved that model, and then we ran the classifier, which gave us an accuracy of around 88 F measure, which was fairly good. In case of the classes where more data was available, the F measure values were pretty high. So now once the Tomcat container is ready, so we have the URL ready where we can request a particular page to be created. So in this case, all the stubs in that particular category of diseases are loaded, and we can choose any particular title. So in this particular example, we'll show you so the disease stubs, you can see there were around like 500 stubs in that particular category on Wikipedia. The first in that is the 2014 enterovirus outbreak, and we choose that and we click create wiki content. And once we click that, a lot of processes goes on in the backend. So let's take a look. So first we have a key phrase extraction. So it filters some terms from the introduction content of Wikipedia, uses those terms to guide the search on Google, and retrieve a lot of URLs. In this case we retrieve around 20 URLs. And the content of that is retrieved using identifying some boilerplate removal so that we get only the useful content out of a website. We extract all those paragraphs and the initial classifier which we had trained, that is used to classify those paragraphs and put it into separate sections. Now once each section has, say, maybe 5 or 10 different paragraphs, we apply a multi-document summarization module which uses LexRank as an unsupervised summarization algorithm, and on top of that we apply sentence compression for a minor rewriting approach. So finally, the content which has been retrieved and put into separate classes based on the importance, as well as after applying sentence compression, we finally have the content within this text area on the UI. And this is basically in wiki format, so we can just go ahead and copy paste it on any Wikipedia page. So we can see the example here. We actually go to a user sandbox on Wikipedia, take that content and just put it there and save it. And once we save that content, it's in the form of a Wikipedia page, and there are no formatting errors. So this is in the sandbox and not in the actual user namespace, but we can also go and check the current content of that particular article on Wikipedia. So as you can see, in each of those classes, the content fairly identifies well with the section titles. So the classification module works pretty well and extracts relevant content finally from the web. We also take a look at the original article of the stub, which we have improved. So we had made an edit using our algorithm on 5th of January, and the last edit which was made was back in October 2014, and the content was just one section other than the introduction, and we incrementally added various sections like epidemiology, causes, and prevention using our algorithm. And finally, this is the current state of that page, which is a much improved version, and it has stayed in Wikipedia for quite some time. It's been around 15 to 20 days, and the reviewers have probably taken a look by now, and there weren't any major edits, so our algorithm successfully has created good enough content in this case. So if we have to create another article, we just come back to this screen and choose another subtitle.